Hello, everyone, and welcome. We're so excited to have you join us today for another exciting and insightful session. Today, we are diving into one of the most exciting and groundbreaking initiatives in Morocco, the Marwan Supercomputing Center by CNRST. And who is better than Mrs. Bushra Rahim to take us on this journey? And Mrs. Bushra Rahim is actually a key member of the HPC-MARWAN team. And she has been working on the forefront of HPC in Morocco, which involves helping and empowering researchers and industries with the computing power they need to tackle very complex problems, be it in science, technology, and other fields. For those of you who are not yet familiar with Morocco HPC, our initiative, it's actually all about building a vibrant community around high-performance computing. So we're here to support and connect researchers, professionals, and enthusiasts who are passionate about using cutting-edge technology to solve real-world problems. So whether it's accelerating AI research, enabling complex simulations, or simply supporting critical data analysis, it is really important to understand that HPC is playing a huge role in driving innovation. And Marwan Supercomputing Center is somehow at the heart of it. Today's session will give us a closer look at how Marwan is changing the game. Providing top-tier computing resources to researchers across Morocco, and eventually opening up doors for collaboration and discovery. So for today's webinar, we're also joined by Dr. Ahmed Qisami and Dr. Hassan Layoni, who are the heart of Morocco HPC, and they are with us today to enrich the discussion. So get ready to dive deep into the world of supercomputing, and let's have a good time learning from Mrs. Bushra. So Bushra, thank you so much for accepting my invitation. And without further ado, I'll hand it over to you.
Thank you, Safa. Assalamu alaikum jami'an. Hello, everyone. And I'm so excited to be here with you. And was also excited when I learned about your initiative, Morocco HPC. So thank you for the invitation. So for today, I will try to present our project, HPC-MARWAN, and the cluster that is provided by CNRST. So in my presentation today, I will begin with a brief introduction to our institution, CNRST, its mission and services. Then I will introduce our HPC cluster, its architecture, usage, and workflow. Next, I will present some relevant numbers and success stories as outcomes of the project. Finally, I will conclude by discussing our future plans for the projects, inshallah. So CNRST stands for the Centre National pour la Recherche Scientifique et Technique. It's the National Center for Scientific and Technical Research. It's a public institution dedicated to promoting and supporting scientific research and technological development. Its mission is to enhance and foster scientific research and technology transfer activities according to the country's cultural, economic, and social needs. It's important to note that CNRST's role is not to directly conduct research. We're here to provide funding, resources, and infrastructure for research institutions and projects performed in universities and technological institutes. So to achieve its mission, CNRST relies on three key pillars. The first pillar is research support and funding, where CNRST provides financial support to researchers through competitive grants and funding programs, offers scholarship to support doctoral students, sponsors conferences, workshops, and seminars to facilitate knowledge exchange and networking among researchers, supports the publication of scientific books to disseminate research findings, fosters international collaborations and partnerships to enhance scientific research. The second pillar is research valorization through TechTemkin initiative. It aims to bridge the gap between research and industry by promoting technology transfer and commercialization. CNRST supports innovative projects and encourages business ownership among researchers and facilitates partnerships between academia and industry to promote applied research and innovation. The final pillar focuses on research sharing, which we call pool of resources. With this approach, CNRST makes substantial investments in resources that would be too costly for individual universities. These resources are then made freely available to researchers, enabling cost reduction across institutions. One of the units is IMIS, the Moroccan Institute of Scientific and Technical Information, CNRST's Information and Documentation Center. It provides access to a wide range of scientific resources, including databases, journals, by investing in annual subscriptions to leading academic publishers, including Elsevier and Clarivate. IMIS also maintains a database of Moroccan theses, provides access to anti-plagiarism solution, and has an on-premise library. There is UATRS, Technical Support Unit for Scientific Research, which offers state-of-the-art equipment and analysis platforms for researchers. There is ING, the National Institute for Geophysics, that provides seismic monitoring services and maintains a database of geophysical data. And then there is MARWAN, which I'm a member of, that manages the National Research and Education Network and provides the HPC platform to researchers in Morocco. So in the next slide, I will give more details about MARWAN unit and its infrastructures. So MARWAN has been established in 1998, is one of the Africa's first national research and education networks. It's in its fifth generation and provides high-speed connectivity among academic and research institutions across Morocco that support collaboration and knowledge exchange nationwide. MARWAN also offers internet access and have a direct link connection to GEON, the Pan-European Research and Education Network. Additionally, it provides advanced services at the national level that university IT teams can easily deploy or use, such as EduROM, Identity Federation, Trusted Certificate Service, and so on. So MARWAN 5 connects over 250 institutions across 51 cities, serving more than 1 million students and faculty members throughout Morocco. And as the resource pooling agent for IT, MARWAN enables researchers from all Moroccan universities to remotely access high-performance computing infrastructure, HPC, supporting a diverse range of research fields. So now let's take a closer look at the high-performance computing infrastructure provided by MARWAN and CNRST. So as you know, the basic architecture of an HPC cluster consists of the following elements: compute nodes interconnected via low latency, high bandwidth network, a data storage space, and finally an access node. It's a login node machine that allows users to access their HPC workspace. Concretely for MARWAN, here is an overview of the HPC cluster, which is composed of nodes interconnected through the high-speed network. For now, we have 100 gigabit per second. The cluster includes the following types of nodes: management nodes that manage system operation, including provisioning of images and upgrades over a 10 gigabit per second network. There is a login node for user access, authentication, job submission. So HPC-MARWAN login node is connected to MARWAN network with a 10 gigabit per second link. There are some storage nodes that provide storage for system resources, such as home directories for users, software repositories where we install the software, and user data where they store their data. Parallel file system nodes, that is a shared file system which provides high throughput, low latency access to storage across the compute nodes. By its name, it's called /scratch for our HPC. By its name, it suggests that it's a temporary storage area for intermediate data and results of running simulation, and is not intended for long-term storage, unlike the others. So there are a number of compute nodes that perform the actual computation powered by Intel Xeon Gold processors. We have big memory nodes that have large amounts of memory, making them suitable for applications that require extensive memory resources. And finally, we have GPU nodes that have graphic processing units, which are specialized processors used for accelerating certain types of computations. We currently have two types of cards: NVIDIA Tesla P100 and NVIDIA Tesla V100, which has a dedicated deep learning course. So HPC-MARWAN runs on Red Hat Linux for HPC, uses Slurm as its job scheduler, workload manager, and have Intel One API for development and optimizing applications, and BGFS as a parallel file system. So HPC Marwan offers a total of 1,672 CPU cores, more than 10 terabytes of system memory, and almost 400 terabytes of storage capacity. So only PhD students and teacher researchers are eligible to use the cluster. To request access, you simply need to fill in the form in the web link I mentioned and send it to the HPC team at hpc@marwan.ma using your institutional email address. The users have to comply with the HPC user charter that is shared in the website also, which include mentioning CNRST HPC-MARWAN in any publication resulting from the use of HPC in the acknowledgements and funding text. So we given this example as an acknowledgement. This research was supported through computational resources of HPC-MARWAN provided by the National Center for Scientific Technical Research, Rabat, Morocco. This helps us identify publications and articles that has resulted from using our infrastructure. And then the user has to provide the version of that publication to CNRST. Sorry. So once the access is granted, the user receives their credentials to access HPC environment remotely via SSH. First, the users enter their unique username and password to verify their identity. Next, for additional security, we've added a two-factor authentication method, which relies on a verification code generated through a Google Authentication app on the user's phone. And he enters this verification code as the final step. So this helps us prevent unauthorized access by adding an extra layer of security. Users can manage software environments by loading and unloading modules using the tool LMod, which makes it easier to control versions of applications and libraries available to users on HPC system. And the users can submit jobs through Slurm workload manager, which allocates resources and schedules executions on the HPC cluster. So we use classic tools such as, I think, UMC-SPE and other HPC clusters. The typical workflow of usage is first, the user deposits inputs file in the user personal directory. Users have specific storage allocations, as I said, in /home/data. Next, the user prepares a Slurm jobs submission script. This script, where he specifies the resources required for the job, such as the number of CPUs, memory, time limit, and loads any modules needed. Finally, it includes the commands that will launch the simulation. Once the script is ready, the job is submitted to Slurm command, typically sbatch. Slurm will then schedule the job based on resource availability and queues policies. While the job runs, the user can monitor its progressing using Slurm commands like sq to see the job status and scontrol for more details about the job. This allows them to check if it's waiting in the queue, running, or completed. Finally, once the simulation is complete, users can retrieve the output data and results for visualization or for further analysis. So HPC team, currently we are a team of three members. Hopefully we will be four next year. So the HPC team offers a range of services to ensure the smooth operation and efficient usage of cluster. We ensure that HPC infrastructure is available and optimized for high performance, continuously working 24/7 to maintain and improve system efficiency. Installation of or upgrading of scientific program. We offer expert technical support to users, assisting with issues related to hardware, software, or any job executions. And we offer training sessions and workshops to help users become more efficient with the HP environments, providing guidance on job submitting, job scripting, resource management, and all the best practices for HPC. So now let's look at some outcomes of our cluster. So in the past year, our HPC infrastructure has been utilized by over 500 active researchers. And since its launch in 2012 and 18, we've created accounts for over 1,300 users. To support diverse research needs, we've installed more than 150 scientific software and packages and conducted over 30 training sessions. So the cluster has a high utilization rate of 92% and the allocation of over 40 million CPU hours. Researchers have submitted over 290,000 jobs, contributing to over 120 published research papers that we know of. So the most frequently used applications include Quantum Espresso for material science, Geom4 and Gate for physics, GROMACS in life science, and TensorFlow and cuDNN for artificial intelligence. You can find a comprehensive list of all the installed software in the website. So in this slide, I have selected several compelling examples of how our users have leveraged HPC resources to address critical challenges in various fields. So in material science, one of our researchers investigated the effect of biaxial strain on the optical and electronic properties of advanced materials. The aim was to help identify how mechanical strain affects the optical and electronic characteristic of materials and to enhance their performance for applications in flexible electronics. In physics, there was a Monte Carlo simulation of graphene nanoporous membranes for water filtration. This helps assess the feasibility and of graphene-based membranes in filtering impurities from water, addressing the need of efficient, cost-effective filtration technologies. And in AI, deep learning tools were applied for forest fire detection using drone images. The aim is to improve early detection of forest fires through automated analysis of drone images, aiming to minimize response and reduce the risk of large-scale wildfire. So you can find the exhaustive list of all research papers in the website also. As for our future plans, in the coming months, we plan to expand our data center and computing resources. So first, we will add more racks and ensure better cooling with additional AC units to support the growing infrastructure need. We will also expand the cluster by adding more compute nodes, big memory nodes with more than 2 terabytes, GPU nodes with the next generation of graphical cards. And to improve the user experience, we plan to introduce more login nodes, especially for visualization purposes, as well as a data transfer node to optimize data management. Additionally, we will implement a web portal, allowing remote access to the cluster while reducing the time it takes for users to start their first job. This is for the users who have difficulty manipulating Linux and shell scripting. Finally, we will look into acquiring proprietary software to enhance our capabilities and meet growing demands for scientific research. So for more information about HPC-MARWAN, please visit our website. You can also check our user guide, where we share how-tos and tutorials for using the cluster, as well as the GitHub repository containing sample scripts that users can copy and customize to fit their needs. If you would like to get in touch with us, feel free to contact us at hpc@marwan.ma, and thank you all for your attention.
Thank you very much, Bushra, for this presentation. It was actually very insightful. Thank you very much for presenting all the details of how Marwan is actually working and like the different things that can be done on the Marwan supercomputer. So we're going to wait for the audience to type in their questions. And in the meantime, I'm going to ask Ahmad if he has any questions.
Thank you very much, Safa, for the introduction and for making this webinar. Thank you, Bushra, for this comprehensive presentation. So I have maybe a question about the GPUs. Like, so you told us that you are aiming to add more GPUs. Could you please tell us which GPUs you will bring?
So for now, we're thinking of the L40S of NVIDIA. So before we were thinking of getting the H100 and A100, but the cost was too high for us. So we're thinking of having a mid-range, still a powerful GPU for data centers, which is L40S. But it's still we're still thinking about it. If you have
Okay,
suggestions on how you have in UMC, we could use your advice.
inshallah, yes, we can discuss about that. Yeah. And how many GPUs you will bring?
Maybe eight more, because for now we have four, and the users that need them for not only AI use cases, but also for general purpose GPUs, such as I said, GrowMax and other scientific applications that start to harness the power of GPUs. So we will try to double the amount. So maybe add eight more.
Okay, thank you very much. So, and the ones that you have now, it's the P100, yes, or the four are P100. That's right.
P100 and Volta V100.
V100. Okay,
We
okay.
added this in 2021 because we had some users requesting a deep learning course.
Okay. Thank you very much. That's fine for me. Thank you.
Okay. We have a question from Fuad. He is saying, hello, is there any open PhDs for an embedded system engineer in Marwan HPC Center?
So we don't offer PhD projects, as I said in the introduction. CNRST doesn't do research. So, but maybe if you are already enrolled in a PhD doctoral studies and need HPC resources or maybe our guidance, you are more than welcome.
Okay, I hope this answered the question from Fuad. Sil Hassan, do you have any questions for Bushra?
Yeah, sure. Thank you very much, Safa, for this
My pleasure.
taking care of this webinar. And thank you so much, Bushra Rahim, for a nice and clear presentation. This is something we have to know about this supercomputing in Morocco. I have actually two points.
Yes.
The first one is the access to the supercomputer. How like frequent you can have access to the machine, like you can have access anytime, or is it like very limited time to use yes, that's the
So
first.
we have in Slurm, as you know, there are partitions to split the resources. So we have the longest partition you can use is for 30 days, 1 month. But it's usually used by people who have sequential jobs. We have other queues for short jobs of 24 hours, and for medium queue jobs for 7 days. And then the following is, as I said, 1 month.
Okay.
A single run.
Okay, so my second point is I'm curious about like you talk about the industrial applications, like in Morocco. What kind of applications? I mean,
So I'm not familiar exactly with the industrial impacts, but there is a unit specialized in CNRST for tech transfer that I can share the contact with and with you and explain more in details what are the activities that they do. So they do a lot of trainings for researchers on how to pitch their research result as a business idea and how to contact industrials to get fundings for their projects. So the aim is to bridge the gap between the academia and the real applications of the research products.
Okay, thank you so much. Really, it was good. Thank you. Thank you so much.
Thank you very much, Hassan, for the questions. I actually have a question, again, waiting for the audience to type in their questions. So you mentioned that the cluster is actually used for different applications in different domains. So this actually requires sometimes new software or new packages or new libraries. So how do you handle that? Like when you have a user who needs a library that you don't have installed, do you give them the right to do installations by themselves, or do they have to like submit a ticket or something for you to do the installation?
So both. If he knows and has some expertise on Linux, he can install whatever he needs, but only limited to his environment. But if it's something that can be shared with other users, it's interesting library or software, we install it by ourselves and share it with the whole community.
Okay, and it's handled as modules, right? Or
Yes, using L mode. So
okay.
each software has its own dedicated folder with the binaries and the libraries, and we can manage multiple versions of softwares, which was very useful because our researchers need multiple versions at one time.
Yeah, exactly. That's always like a question, like
Yeah.
different versions, as you said, different software, different libraries and stuff. So yeah, that's actually helpful. And for the queuing system, like how many queues do you have, and how do you do like the queuing system? Does it go by priority or?
It's by priority. So Slurm manages all of this for us, thankfully.
Yeah.
We have organized our resources at different level queues. I mentioned 3 for Mr. Lehsen, but there is another GPU queue that is dedicated for researchers who express the need of using GPUs, and we monitor those resources because they are rare in our HPC very closely. So we don't allow a CPU usage on GPU nodes. And then Slurm uses a backfill algorithm that, depending on the size of the job, decides of its priority and tries to handle the queue as efficiently as possible.
Okay, so the priority is decided based on the size of the job,
Yes.
right? Okay. Yeah, okay, that's perfect. See,
Maybe,
Ahmed? Yeah.
yeah, I have a question about cooling system. So, what is the cooling system that you have? It's a air cooling system or
Yes,
water
it's
cool?
air cooling system. Currently, we have a data center, integrated data center, that offers IT racks and AC units inside the data center, which provides cooling air for the equipment.
Okay, and I have another question. How you manage the nodes and so on? So it's an open source solution that you made by
So
yourself. It's open
until
HPC or
until recently, you had a proprietary solution, but we haven't renewed with them. The cost has been proven to be too much for us, so we're trying to switch to open HPC.
okay. So
Okay.
Werewolf and Open HPC. So we are in process on thinking of other solutions to manage the nodes in the cluster.
okay, cool. Thank you.
Okay.
No.
I have another question.
Yes, yes.
So you said you mentioned that when there is a user, for example, I would like to use the cluster. So I have my own data, right, in files, multiple files. So I do transfer that to the cluster, right?
Yes.
And then it gets stored in the distributed file system. It's a distributed file system that you have, right?
We have multiple. We have a network file, shared file
Okay.
system, NFS, and then the distributed file system is only for parallel jobs. So when there is a simulation that requires to have multiple nodes, we recommend to the user to stage the data in one of the slash scratch the directory, which has a high speed and low latency access to the data for the compute nodes.
Yeah. And do you have any like regulations or policies for data retention?
No, for now, no. So maybe one of the perspective of or future plans is to offer storage, permanent storage system. For now, we tell our users that maybe if the data is not needed in 6 months, it shouldn't stay in the HPC because
Okay.
it will fill all the data capability we have. Some request more time, so we will need to figure out a solution for them.
Okay. So if the data is there for longer than 6 months, it's deleted?
It's not automatically deleted, but we remind them frequently to clear some space in their storage areas.
Okay, that makes sense. Yeah, because at some point it gets it gets full and it's tricky
Yes,
to free up
exactly.
space. Yeah. And you mentioned that researchers and PhD students can have access to it, right?
Yes, yes. So it's
Is it
access for everyone who is eligible. The user have to be a PhD student in a public university. And sometimes we allow private universities if there is a collaboration with a public university. And then, and also the researchers, the teachers and researchers. So, enseignants-chercheurs.
okay? Yeah.
Well,
And there is no like for I don't know individual researcher.
for now, no, because we are a publicly funded institution. We have our target, which is the universities.
Yeah. Okay. So the access it's through their university accounts, right?
Yes, when they reach out to us for some, we have to know that they are from the university, so they have to use their university account,
Okay, I see.
institutional email. Yeah.
Okay, perfect. That makes sense. Thank you very much.
Yeah.
I don't know if someone from the audience has any questions. We have Sisam who says thank you very much for this insightful presentation. It was indeed very insightful. Thank you very much. Seimat, Silhassan, do you have other questions for Bushra?
No, I'm fine. That's
No,
good.
that's fine for me. That's good. Yeah.
Most welcome.
Thank you very much,
Thank you.
Bushra.
You're welcome, Ahmed.
Yeah, thank you very much, Mrs. Bushra. It was really great to like talk about the Moroccan efforts into like having HPC systems that researchers, as you mentioned, can use. And you know, a lot of people again talk about AI, but a lot of people do not have the resources like to train their models or to use proper AI. So it's really amazing that we have such an initiative that is actually allowing innovation and allowing research and enhancing it. So thank you very much for talking about it today, for presenting it to us today, and thank you very much again for accepting my invitation. I know it's a lot of inconvenience for you, and we discussed that.
It was a good opportunity to speak to a wider public. Usually, we do presentations to a small community for HPC trainings and or students that can visit the center. But now I would like to take this opportunity and.
So yeah, actually, how we can visit the data center, Bushra?
It's just upon request to Madame la Directrice and we
via
can
the email, Marwan.
For now, it's usually a letter from the institution or the teacher who invites his students to come to see us, and they talk to me to arrange for the best time and date.
Okay. Maybe we can plan some visits, Charm.
Yeah, I was gonna say maybe same as we can schedule a field trip or something to the cluster. Yeah. All right. Sil Hassan, I don't know if you have any.
No, just thank you so much, Bushra, and I'm looking for an opportunity also to visit the center.
Marhaban, welcome anytime.
Yeah.
Thank you.
Okay, great. And thank you very much for sharing your contact. I'm pretty sure other people will get in touch with you to learn more about this. And yeah, thank you very much. Thank you very much, Bushra. That was really nice of you. Thank you.
Good luck with the initiative.
Thank you very much. Thank you. That's very nice of you.
Assalamu alaikum.
مع السلامة.
Bye.